Hello, this is Miguel Cabrera from the Sautenkov Institute of Science and Technology, Tech. I am glad to present our work, DeepXPalm, tilt and position rendering using palm-word haptic display and CNN-based tactile pattern recognition. Telemanipulating deformable objects require a high precision and dexterity from the users, which can be increased by kinesthetic and tactile feedback. This work presents a telemanipulation system for plastic pipettes consisting of a multi-contact haptic interface link light to deliver haptic feedback at the user's palm and two tactile sensors arrays embedded in the two-finger robotic gripper. We propose a novel approach based on convolutional neural networks to detect the tilt and position while grasping deformable objects. The CNN generates a mask based on recognized tilt and position data rendered for the multi-contact tactile stimuli during the telemanipulation. Since the resolution of the haptic interface is lower than that of the tactile sensors array, data preprocessing is required to achieve an effective tactile information exchange to the user. In the first stage, the downsize method resizes and adapts the sensor's data array to the dimensions of the haptic display, with a unique stimulation point per row. The second stage proposed to use a set of predefined tactile patterns as mask arrays, which use depends on the CNN estimation. We have implemented a classification CNN model with two heads for pipette angle and position recognition. To acquire the dataset, we have used a pipette holder to set off 12 use cases. The angle classification problem includes 4 classes, and the position classification problem had 3 classes, representing the distal, middle, and proximal sections of the gripper fingertips. In the test accuracy, the angle perception model achieves 95%, and the position prediction model 93.98%. The experiment evaluates how the tactile feedback with base mask data improves the user's perception compared to the direct downsizing haptic feedback. During the first experiment, the tilt and position perception was rendered directly from the sensor's data to the user's palm by the haptic display using the downsize method. During the second experiment, the CNN classification performed the data masking. Each of the 4 angles and 3 position combination was presented 5 times blindly in random order. Using only the downsize method, the overall recognition rate was 9.67% and the overall recognition time was 3.97 seconds. The overall recognition rate using the CNN mask was 82.5% and the overall recognition time was 3.13 seconds. Based on the experimental results, we can conclude that the using of multi-contact tactile feedback on the user's palm combined with the CNN-based rendering methods can potentially improve the manipulation of the deformable objects. The proposed system can be applied at remote co-working labs, improving the dexterity manipulation and the user response. For further information, you can consult our paper. Thank you very much for your attention.